Hello, Patriots. My name is Joseph Moore, and you're watching The Jalden Show. This is actually my third time trying to record this, so let's see how it works out. Basically, we got this problem. I'll give you a little context behind this problem. I did math club the other day, and I did nearly perfect, and this is the only problem that I didn't get right in the time allotted, and you'll see why, because it's just absolutely crazy. There's a lot of work that goes into it, and there's a lot of math that you might not know that goes into it. So I guess I'll read out this problem. I'll talk to you about the math that goes into it, and then we'll start solving it. Okay, so the ratio of the constant term in the expression of this to the constant term in the expression of this is 5 over 3. If n is a positive integer, this is the n, by the way. If n, which is that, if n is a positive integer, compute the value of n. So this is what we're trying to find. This is what we want to do. So this is another slide that I've prepared. This is basically the definition of raising something to a power. When you raise something to a power, you're just multiplying it by itself a number of times. So that's the definition. So let's say we want to expand this, FOIL it, as you might want to say. We'll say that, okay, so the x plus y, sorry for my handwriting, to the n is equal to, well, what is it equal to? How it's, well, when you FOIL something, when you multiply something out like this, you do the total number of combinations, well, everything in one, like each term gets multiplied by each other term at least once. So like if it were just like just pretend that these two terms weren't here, it's just this and this, you multiply this term, and then this term, and then this term, and then this. It's each possible combination of terms. So I'm gonna just re-get those things out. So if you look at each possible combination, or how many possible combinations are there to multiply together x's? Well, there's only one way you can multiply together x's in here, and that's just x by x by x by x by x. So you got x by itself time. Well, how many times? How many times are you multiplying? You got it n times. So x times n. Okay, so what's next? What's next? You got how many possible ways are there to multiply together let's say you want to get 1y. Let's say you want to get 1y in there. Well, there are n terms with a y in it, so you can multiply together like this x, this x, this x, and that y, or this x, that y, and this x, or this x, that y, this x, and this x, or this y, this x, this x, this x. So I mean, there's how many terms there are, there's that many y's, and that's the total number of ways that you can get the same equivalent term. So we're going to put n right here as our coefficient, and then x you're going to multiply together n minus 1 times, and then you're going to multiply it by y, and because you're only getting 1y. And notice how the terms right here, these exponents, add up to the n value right there. Alright, so you can continue on, but it gets a little hairier after this, so I'm just going to tell you what it actually is. I've been stressing on saying that it's the combination, and in mathematics we have a way of expressing combinations, which is through the notation, combination notation, N C R. This is the number of combinations per amount you choose, which is R, which is equal. I mean, it's different notation, but it means exactly the same thing as this, N over R, kind of in the parentheses right there. And mathematically, this is equal to the permutation, which is NPR, not the radio show, but the permutation over R factorial. R factorial. Like, imagine you have a deck of 5-card hand. You have like a 2, 3, 4, and 5 and a 6. You got 5 cards in your hand. It doesn't matter what order those cards are, and you're still always going to have a straight. So the number of cards that you can have, the number of combination of hands that you can get that are equivalent is 5 factorial, because you got 5 cards. 5 of those could go in the first kind of slot in your hand. 4 of those, the 4 remaining, any one of the 4 could go in the second slot, and then 3 could go in the third, 2 could go in fourth, etc. And NPR is equal to basically what I just did, the 5 by times 4 times 3 times 2, or you can do it, it's just kind of any string going down, and then you can divide out how many terms you want. So that's, I'm just going to give it to you. It's n factorial over n minus r factorial. So this will cancel out all but the first r terms. So like if n were 17 and r were 5, then this would, like 17 minus 5 is 12. You get 17 times 16 times 15 times 14 times 13. But 12 times the rest gets canceled out by this term. And then divided by r factorial, which is what this thing was right here. So this right here is our definition of combination. Alright, and it turns out that, you just keep on doing the combination right here. It'll come out to be, you got n, choose 2 of, well, oops, sorry, that's an x times n minus 2 y squared, all the way up to 1 times, which is n, choose n, y to the n, and then the x term would be 0 right there. So the actual notation of this is the binomial theorem, is the sum from r is equal to 0 to n, whatever your n value is, of the combination n over r, or not n over r, that's n choose r. You have n and then the choice of r number times some function, we'll call it x. X doesn't actually have to be a single value, it could be like a value squared or something like that. Like x could actually equal x to the 4th sine x. It doesn't actually have to equal that, but it can. I mean that's bad notation, but whatever. And then how many times are you multiplying? Well, the first time you do it, you're getting n, and then the second time you keep on degrading, so that depends on the r value. And then you get y, and then, well, the first time you do it 0 times, and the second time, so it increases with r. So it's that sum. This is our definition of the binomial theorem that we're going to use. Well, it's not our definition, it's the definition of the binomial theorem. So I spent enough time talking about this stuff, so I'm actually going to cut this video right now, just because it's been acting a little buggy, and then I'll start doing this one in another video, now that you know the basics behind the binomial theorem. Thanks, and I'll see you in the next video. Oops, function f.